space. We are about to kick off session 2 here, live broadcasting around the world. Session 2 is dedicated to sea and space synergies. We introduced this session with a range of speakers from across the world, talking about all kinds of expedition, exploration, and activity from the depths of the ocean to the hostile realms of outer space. Our species has yearned to explore and to push the boundaries of knowledge here therein. The Tektite program joined together normally siloed communities, and its influence carries out today. In this session, we are going to speak with world-renowned astronauts, astrophysicists, and aquanauts to discuss groundbreaking and synergistic projects. From field studies in the ocean that are informing deep space travel, to stratospheric flying laboratories, to deep space exploration and habitat missions over many decades, our panelists share their passions, their projects, their hopes, and their dreams for the future. It is with great pleasure that I introduce our first speaker of the day, Dr. Peter Weiss. He works, he's the director of the Space Department at COMEX in France. Peter has had more than 15 years' experience of both the management of the industrial and the research projects occurring in deep sea and human exploration space-related projects. He has been working on European Commission projects with the European Space Agency, with the French Space Agency, CNES, industrial clients, and coordinating projects all over the world. We're looking forward to hearing what COMEX is up to and relating a parallel journey to the Tektite 2, a 1 and 2 program, to that was occurring in Marseille Bay, all the way on the other side of the planet. Peter, welcome.
Thank you, Sarah. So I will start my presentation. I hope you can see my presentation in a few seconds. Maybe you just can give me a head up if that is working. Can you see my presentation?
Yes, I can. It's full screen. Looks perfect.
Okay, perfect. Thank you very much. So I'm going to give a presentation about our activities here in COMEX. As Sarah already said, we are located in Marseille. Actually, the history of our company, as I will present it, is originating in the sea, and now we are also working in the space sector. So I try to trace a little bit this journey. Actually, the real name of the company is not COMEX. It's Compagnie Maritime and Expertise. So we have been founded in '61 by Henri Germain Delors, which you can see here on the right side. And actually, the whole story started with a company that was active in professional diving. So you see some pictures here of our history, starting with saturation diving, where we operated on oil and gas platforms and almost any oceans of our planet here. We had big ships like seen here on the second picture, and to our knowledge, we still hold the deep diving record to 701 meter, with these 3 gentlemen here on the third picture. Having said, it's only the gentleman on the left who went to 701 meter. So that is a little bit our past. Now we are looking in different fields. I just would like to mention the last picture here. It's a deep sea mining system on which we were working some years ago. So today we are looking also in other fields of intervention. So what is really interesting for us is human and robotic intervention in extreme environments. Sarah already explained a little bit where I am right now located. So in the south of France, in Marseille. We have quite a nice place here. I'm not originally from Marseille. I'm from Germany, as you might hear. But yeah, it's a nice place with a wonderful seashore too. Our headquarters is located here. Here you can see our site, where we have quite a lot of facilities that can be used for various purposes. So from pressure chambers, we have test pools, pressure chambers that can be used for human tests, but also pressure chambers that can be used for testing robots and things like that. Like, for example, the big one here on the right side, which is the C4000, which can go up to 400 bar for testing of offshore equipment. We can also do tests with humans in the loop, so not only underwater but also in the other direction and hypobaric conditions. So, like, for example, as you can see on the left side, testing masks, or we also have some kind of flight simulator where crew can train hypobaric conditions. Or as you can see on the right picture, spacesuit, that was a stratospheric suit that we tested in our facilities. So one of our expertise is clearly pressure. We like to develop special machines for various kinds of applications. What you can see here on the left side is a machine that we developed for Rolex, testing Rolex watches to 600 bar. So if ever you found yourself with a Rolex in 6,000 meters depth, then the Rolex is still working. But we also do other kinds of machines. The one in the middle here, for example, is 3,000 bar, if I'm not wrong. Or on the right side, underwater habitats that were developed in the past together with Jacques Rougerie, with whom we work quite a lot together. We also use robots, not only human divers. We work a lot on photogrammetry in order to construct 3D models of underwater sites or things underwater that can be like a plane wreck, which is here in the Bay of Marseille. But that system can also be used for the offshore industry or for biology and things like that. Now I'm coming a little bit more to the space sector, which I take care of. Actually, that whole story started with the concept that astronauts can be trained underwater for neutral buoyancy simulations, and that started already quite some time ago in '87 with the training of astronauts for EVA, so extravehicular activity. That pictures that you see here were in our pools in Marseille with the French and Russian astronauts, and actually they trained for installing some kind of antenna on the Mir station. So we built a mock-up of Mir station, had that in the pool, and had the astronauts trained, and that flew then, and they deployed the antenna on Mir station. And that continued like that. We also participated in the Hermes project, which was supposed to become the European space shuttle, a little bit with the same principle, training underwater and testing underwater ergonomics of EVA and also of IVA, so intravehicular activity. Like, for example, as you can see here, the installation of racks in microgravity, which can be very easily simulated underwater, in order to check if the ergonomy is okay. That was for the Columbus laboratory. Then this activity stopped a little bit. We went out of the space sector and we started again around 2012, 2013. I mentioned here one mission that was quite interesting. We made Apollo 11 under the sea together with the European Space Agency. So we had Jean-François Clairvoy and the French astronaut, and Hermes Training, who's astronaut trainer at the European Astronaut Center, playing Apollo 11. So I hope you can see the video here. That was not very deep, and the idea was seeing if we can already set up the infrastructure here in Europe, in Marseille, in order to do this kind of simulation. So you can see he is clearly in lower gravity. It's not microgravity, it's lunar gravity, but he doesn't weigh what he would weigh on Earth. And that continued then with a European Commission project called Moonwalk, which had as main objective to simulate robot-astronaut cooperation and test different schemes of astronaut-robot cooperation. So we did tests in the field. These photos here are taken in an analog site in Rio Tinto. So we had the spacesuit, we had a robot from Germany, we had a habitat, we had sampling tools developed by by Liquefer in Austria. We had a mission control center in space applications in Belgium, and also EVA information system. So we tested different kind of applications and things like that. And this whole infrastructure was tested, so on land, if you want, in dry condition, and also underwater. Exactly the same thing, except the habitat. We couldn't put that underwater, so we used one of our ships as to replace the habitat. Continued like that, then studies for the European Space Agency. What you see here, I hope in the picture, is the pool in the European Space Agency, and we were developing concepts for underwater missions and underwater simulations for future missions on the moon and also on asteroids. That was in 2015, and the idea basically was, at that time, there were still plans going also to an asteroid, so we included that in our study. And the idea was to come up with different concepts, how we could simulate such space missions underwater in the pool of the European Space Agency, which you can see here on photo 2. And that included then also tests that we did with our suit, with material that was developed by ESA in order, to test if things are working. And we went last year to NEEMO, NEEMO 23, supporting ESA and with the colleagues of NASA, of course, on the NEEMO mission. So that's mission inside the Aquarius habitat. And what we were testing actually an astronaut rescue system. So we used one of our suits here, which is called Gandolfi, to test the system. So actually our suit was playing the injured or the dead astronaut. Today, COMEX is supporting ESA and the EAC with divers. So these are the men and women in black here that you can see that are helping the training, helping for the training of the astronauts in Cologne, in the pool in Cologne. So we have one full-time staff in Cologne and around 15 freelance divers for this activity. We are not only working underwater. The sea somehow opened the door to this space field, but now we also participate in engineering, space engineering. So, for example, the Lunar Gateway. I'm not going too much into detail, but just to show, so this is the future space station that hopefully will be built or brought into lunar orbit, so not turning around Earth, but around the moon. And it will be quite an international station, so there are elements coming from the US in blue. There are elements coming from Europe in reddish here, and then from other international partners in gray. The configuration, as you can see here, is not the actual one, but I like the drawing quite much because it shows the international character of that thing. And in the frame of that work, we participated with Airbus on the development of an airlock system for the European Esprit model, which was at that time this one here. So same, we developed a functional prototype of that airlock for testing in dry condition. But since we like very much putting things into water, we also developed mock-ups that we tested underwater. So mock-ups for EVA, like the one that you can see here on the left side, which is in the pool of ESA, or also mock-ups for IVA, so inside the vehicle with an astronaut here operating the airlock. So that study was finished some months ago. We also are very happy to work with Thales Alenia Space and Liquefer on the iHub, which is the second European model, the habitation module. Unfortunately, I can't show much more than this picture, for instance, that project just started. And then, to conclude, we have several other engineering studies like Textiles, where we work on spacesuit materials for lunar mission spacesuits. So it's not normal spacesuit, if I can say like that, but really dedicated to lunar missions with the problematic of dust. And here we look into textiles that also include smart functionalities, such as self-healing, monitoring, and things like that. displays which are included in the textile in order to make these suits more robust and more intelligent. And one of our facilities that we have here in Marseille is called Hydrosphere, and that is one of the newest projects we just started. We started during the COVID, actually. The facility is shown here. It's a complex of 3 chambers, one big chamber, 5-meter diameter, then on some kind of airlock here in between, and then a habitat which has approximately the size of Columbus. And actually, that thing we want to transform into a space simulator. So we have already implemented a rover, a lunar rover simulator here in the front part of the habitat. So one could imagine that is like either a rover or a habitat on the lunar surface. And right now we are transforming the 5-meter chamber into what is called a dirty vacuum chamber. It's not a very nice name, but it's quite an interesting thing. It's basically we pump the chamber empty to vacuum, and inside we have some kind of sandbag that simulates lunar soil. And that's quite interesting because you can test various things like drilling, robots, spacesuits, in situ resource utilization, things like that, in almost like in lunar conditions, meaning no air and this dust. And I think that was my presentation. Thank you very much.
Brilliant. Thank you so much, Peter. You've given us a wealth of projects historically, but also a great expanse of activities now, today in the present, responding even to COVID times and to new missions and continued exploration. So thank you. While we have you, we might ask you 1 or 2 questions really briefly. What is it that you could think of or say is the most significant development over the last 50 years? If we look at the early Cousteau missions and Tektite through to now, in deep space exploration, what is top?
Well, in the last 50 years, I must say I'm somebody who lived in both worlds. I worked a long time in underwater robotics. I did a PhD in space robotics, and I mean, my presentation might have shown that we are trying to build links between both sectors. Yes. So I don't want to judge. It's more important to explore space than sea, or the other way around. I think it's
synergistic.
Exactly. That's not the question.
Yes.
It's not the question putting money in this direction, putting money in this direction, as putting money in both directions, and maybe many other things where we could maybe make economics. On the other end, it's quite interesting because I'm a robot. My education is robotics, yes. But I very much believe in human spaceflight. I think it's utmost important that people go to space, live in space, and that's exactly the same for underwater. Yes. And there are parallels. People went to the moon already a long time ago and didn't return. Underwater, it's quite the same. I mean, we have done a lot of advances in technology development, but today there are no cities underwater. There are very few habitats underwater, and all these things could be fostered and brought forward. So I think this period 50 years ago there were a lot of advances in this direction, and I'm seriously hoping that we are living again some kind of age of enlightenment where projects are going in this direction, because it's utmost important for inspiration of next generation.
Absolutely, and planetary protection. Well, you're in a fantastic place to be able to enable that to happen. So we wish you well.
Thank you.
I'm going to introduce the next Peter. Peter, hang around. We'd love to chat with you later. It is with great pleasure that I introduce a keynote speaker, Professor Pascale Ehrenfreund. She is an astrophysicist. She's currently serving as the chair of the executive board at DLR, which is the German Aerospace Center. She's also president of the International Astronautical Federation. So she has a broader mission in extending her activities not only with the German Space Agency, but with a mission of supporting global space governance, promoting space economy and advancing both planetary and space activities. Pascale, thank you for joining us. I'll leave it up to you. I'm just going to share your presentation.
Yeah. Thank you very much, Sarah Jane. And I also want to quickly say that I'm really honored to be here with you today to celebrate also the 50th anniversary of these Tektite 2 missions. It was quite fascinating to hear from the participants. So the German Aerospace Center is among the largest R&D centers for space and aeronautics in Europe, and it plays a really important role in the innovation chain. And so you are thinking now, what are we doing with the maritime sector or with the deep sea? So I will show you a little bit that, of course, this is very well connected, not only in the fields which you have heard before, but also in future technologies. So I was asked a little bit to talk about future technologies for society 2030, to address climate change. And I will do that a little bit, but then I come back to a very, very similar topic that Peter actually addressed. So when I can have the next slide, when you look at climate change, one of the most important topics is, of course, to reduce emissions and to study, and to improve, our technologies. So at DLR, we are doing many of those things. We are combining many research and technology areas, and such as climate modeling, measurements of greenhouse gases, but also emissions and particulate matter. And you see, I think in this slide, that we are doing really fantastic climate models, of course, with a lot of partners, in order to show, what are the changes in the second half of the 21st century if the consumption of fossil fuels remains the same or even increases. And you see here in this scale that everything what is red and orange, this is a dramatic increase of temperature. So these are very robust models, because I think there is a mixture and a summary of 26 different models. And this is quite impressive. So we really have to do and look at our planet. There is no planet B. And we have, of course, a lot of a large research fleet of aircraft, 15 in total. And we measure greenhouse gases. I will show you in a minute, but also we are testing, the effect of biofuels on aircraft emission, and also, again, their effects on the atmosphere with our research aircraft. And of course, we also develop technology for e-mobility and look in electric flight. So in the next slide, I'll show you a little bit that some of the most important things are, of course, to look at greenhouse gases. And I don't know if you can switch the slide, Sarah. Then I cannot see it, but this is how we are actually looking at greenhouse gases with our research aircrafts. And of course, you focus on some of the most important anthropogenic greenhouse gases, carbon dioxide and also methane. And we're testing with a lot of partners innovative instruments in measuring really, really very accurate greenhouse gas concentrations. So you see here some of our planes. This is Halo, one of our really important research aircraft, which can go in very high altitude and measure even the boundary of the stratosphere and troposphere. And we can here take really, really very, very important measurements. So aeronautics and aerospace is something which is an important topic when we're looking at the reduction of emissions, which we can see in the next slide. It is important for us, of course, to reduce emissions, noise, and we need new aircraft configurations, and we need, of course, also new engines. So we are trying, of course, to develop that and test that. And we are looking, of course, at new research activities concerning autonomous and electric flight. And as you can see here on one of our new airplanes, this is the iStar. It's also called In-Flight and Technology Airborne Research Aircraft. This is a really important aircraft where we will test in the future. Also, I think, environmentally friendly aircraft configurations. And what you see here right now is, I think, a topic where you see that all this belongs together in synergy, many different research topics, in order to have a sustainable, networked and automated mobility. And you want to reach intermodal transport. You need, of course, technical solution for space-based navigation, for Earth mobility. And you need, of course, also new mobility concepts and next generation cars, next generation train. These are all really important topics, and looking at autonomous driving. So combined, you really can provide very important research and technology solutions for sustainable, networked and automated mobility. So I'm coming now to space, and in the next slide you will see the DASIS camera. This is a hyperspectral camera which is developed and built by the German Aerospace Center, but also in cooperation with Teledyne Brown in the US, Teledyne Brown Engineering, and it was brought to the International Space Station in 2018. And really a small camera, but has you know, a lot of channels, and looks at quite high resolution down to Earth. And you see that the International Space Station is also really a very interesting platform to do Earth observation, to look back to Earth. And you can see here also how we look in the coastal regions of the Falkland Islands, looking at the concentrations of chlorophyll. This is something you can do with a really, really small camera, but very, you know, innovative and interesting instrument, which was actually put on a space station in June 2018, and since August 2018 it is actually delivering data, you know, on a constant basis, also of course from the oceans. And in the next slide I show you a few examples how important Earth observations is for monitoring, you know, the entire Earth, the entire environment, land, oceans, and of course also growing cities. And Germany is a pioneer in radar technology and also operates its own research satellites, Earth observation satellites. And these are data from the Tandem X satellite, which actually produced a global digital elevation model of the entire Earth surface. You can see that here on the slides, how the little pieces are put together. And we have from those satellites, we have a lot of global data products. So we look at urbanization, how it grows. We look at forest and non-forest map and how it changes. And with radar technology, you can look day and night and do every weather. And that's really fascinating. And you have a lot of data, and of course also from water regions. And this is actually something which really helps you in the future to develop, you know, mitigations and help in climate change and provide sustainable solutions for the future. When you look at the next slide, you can see how we look with Earth observations to the oceans. And this is actually the Thwaites Glacier. It's one of the most fragile glaciers in the Western Antarctica. And it's melting really, really strongly into the Amundsen Sea in a really a rate which is steadily increasing, and you really have to understand what's going on here because it accelerates, and it has been right now responsible for about 4% of the global rise in the sea level, but it could be much more. And with a lot of Earth observation data, we look into a very detail and what we found with the Earth observation satellite, that there is a really gigantic 350-meter cavity in the floor of the Antarctic glacier, and seawater is actually penetrating and really washing out, the ice into the sea. So this is something, I think, a very strong connection also, apart from the robotic part, for between Earth observations and the sea. In the next slide, I show you just 2 more slides about the German Aerospace Center, and that we have new institutes where we are dealing with maritime security, and particular also with airborne platforms, but also with satellite observations and also other technologies. And maritime infrastructures are really critical infrastructures. And for these reasons, we are also focusing on research and technology development, on the improvement of resilience. And that means, for instance, also looking at trade routes, securing trade routes, ports, offshore facilities. We are addressing the topics of fishery control, oil spill detection, piracy. There is a lot which you can do, with from aerospace technologies and help. And we are also looking, for instance, at unmanned aerial vehicles which can land, on moving platforms under very, very difficult weather conditions at sea. And in the next slide, we are also, this is a very new institute which we just actually really acquired. We are looking at the energy systems of maritime, of vessels, of course, of cargo and passenger ships. And we are looking into the development of integrated system for energy efficient electricity, heating and cooling. And that is a really important topic, as you know, because here we really have to reduce the emissions for the future. So in the next slide, I'm coming back to the topic which also Peter addressed, of course. There is an important mission where a lot of institutes, I think more than 15 institutes in Germany also contributed in a cooperation between scientists and engineers from deep sea and space disciplines. And both groups, of course, encounter inaccessible regions subjected to extreme conditions. We mentioned that already. Whereas in the deep sea environments, it's obviously water, but also really aggravating factors of darkness. And in space research, we have microgravity, we have radiation. But a common feature, I think, of both regions is that navigation, power supply, data communication, those are the things which present major challenges. And when we look at the next slide, in this mission, many scientists have actually worked on innovative robotic technologies, which are key to study ocean processes, but also space processes and prepare for robotic exploration. So there are different platforms, for instance, for underwater research, including 3 types of crawlers, gliders, autonomous underwater vehicles, and sensor systems. And they are developed, during this mission. Also, the very famous Polarstern mission has helped, in order to test innovative technologies in this ROBEX project. And it is clear that the use of new underwater technologies will improve capabilities and also, letting us understand, the effect of climate change on the Arctic ecosystems and ocean observations. And a part of DLR in the next slide is really on looking at Lunar Analogues experiments. We have been, for instance, to Mount Etna, where we tested successfully the interaction between rover, lander, and sensor units. And something which is really important in both areas, deep sea or also, of course, space, is autonomy. Yeah, and the positioning of sensors like here, which were equipped with seismometers, has been tested here. And what's really important is that the rover really scans the environment with camera eyes and plans more or less the route autonomously. And also all these technologies which we are testing, and Robex is a really very, very interesting mission with so many enthusiastic scientists. And we are really a part in DLR in order to test technologies for future moon missions. And of course, that was also mentioned already by Peter. You see a lot of people are actually looking at these technologies. And there's a very, very strong connection between ocean robotics and of course also preparation for space exploration to destinations like Moon and Mars. So I want to end with a topic in the next slide with ocean worlds. We have not much time to cover that, I think, but we should not forget that we have oceans, on other planets and moons in our solar system. These are just a few examples which are mentioned here. The moon Europa, the moon Ganymede of Jupiter, but also Enceladus, the moon of Saturn, and Titan. And there are ocean worlds in our solar system, and there are space missions, and obviously also Mars. We are studying, the water history on Mars. And I think there are many space missions which are looking into the future, because Mars is water is a very, very important element. It is we think it is a key ingredient for creating life, and we want to study, of course, water also on other objects in our solar system to understand if life has developed anywhere else. And in my last slide, I just want to show that also at the German Aerospace Center, we are very active. We are looking at the habitability of planets and in life detection. We have a lot of planetary simulations. Looking at the early Earth, Mars, and we do also a lot of expeditions in our institutes in Berlin and Cologne. And we are also using a lot of exposure facilities on the International Space Station in order to look at extreme life and at icy, including Mars, but of course also for icy ocean worlds in the outer solar system, and participate at many different space missions. And I think this is also, a topic which connects very well. Astrobiology is a very interesting topic that connects, ocean worlds and space. And I think I leave it at that. And thank you very much for listening.
Thank you so much, Pascale. That was brilliant. And we know that DLR is doing an extraordinary amount of work, a complex systems development, not only technology development, but approach strategies for working on these big challenges, as you say, data, power, harnessing and sensing, to be able to navigate, to be able to identify signs of life, but to be able to also support people across this network of systems on planet Earth. So it's brilliant. And you bring a unique perspective too, as planetary scientists with a particular interest in and looking at life beyond the planet as well, to this role, which is really exciting. From a DLR perspective, do you think that their sights for the future of exploration are really set on Mars as a potential habitable zone, or is it more broader than that? Is there an equal weighting between Earth, Moon, Mars, and exploration beyond?
Well, You know, that's space exploration is a field of international cooperation, and we have many different missions. As you right now it's a very exciting time because we have 3 missions which are, be launched to Mars in the next week or next weeks. From the United Emirates, from NASA, and from China. So these are fascinating missions. So it is an active field. The moon is very much in demand right now. There is a lot of missions which are planned for going to the moon, doing robotic studies, but also in order preparing for human exploration, in particular with NASA's Artemis program.
Yes.
There is the low Earth orbit, and there are you have seen this a lot of commercial actors which are playing an important role now also in low Earth orbit activities, and the International Space Station stays a really, really very interesting place to do fantastic experiments. So we have also, we are returning samples, from asteroids in order to understand those objects of our solar system. So I think we have actually a quite rich portfolio of space exploration. Right now, I think the focus is currently on the moon, but with an outlook of preparing, to go to Mars. The only thing what I still want to say is that I think, human exploration on Mars needs to be very well prepared and is still far ahead, I think, because we need to understand a lot of medical constraints before we can do that.
Yes, absolutely. And what do you think what has been the most significant lesson learned over the last 50 years? If we look back to the Tektite program, if we look at the complex challenges that are still facing us today, and what are both the lessons learned and the opportunities that we can take from that?
Well, I think what we have seen in the talks, and I think we will still discuss, is that there are a lot of synergies between the 2 domains of exploration at sea and space. And on a technical level, there is certainly a dual component of human and also robotic exploration for both environments, and also with similar needs. And extravehicular activity and what we have spacewalks, as we call it, and deep sea diving. We have heard that also already today. I think we have learned a lot, and I think there are important technologies which we have to develop for the future. We see that. Or ground and space-based communication and navigation, and to increase our space-based, I would say, Earth observations for maritime space. I think that's important. Big data analysis is important for both domains. Obviously, it is always important, to understand and to, look at this large amount of data and be able really to understand them and to investigate this large amount of data. And I think there are similar technologies which can be used in the future. And it's also, of course, the sensor technology, which we have seen in the previous talks. So from the technology point of view, I think there is a lot to do, which we can learn and which we have actually to develop together. And, on an economic level, I think maritime space is very, very important. And we have, I think, to make a stronger connection between these 2 domains. We have started, but when we look at the last sentence, I think we have a lot of astronauts. I'm not sure. This is other expertise in the panel is how many people have been really very, very, very in the deep sea. I think there are actually more astronauts which are actually on the International Space Station than ever will be in a very, very deep sea. So you see, there are things where we should really improve to work together and learn from each other.
That's a brilliant segue. Well, we, in recognition, we recognize only a month ago that we had Kathy Sullivan reaching the bottom of the Mariana Trench, the first woman to do so. So we're terribly excited, and we agree with you that much more exploration could be occurring both in synergy and in deep sea with human exploration. Thank you, Pascale. We will ask you to stand by and call in somebody who has been involved with exploration from both extremes. It is my great pleasure to welcome astronaut, artist, and aquanaut Nicole Stott. She has worked with NASA for the bulk of her career as an astronaut, including 2 space flights, with a total of 104 days living and working in space on the International Space Station, and also traveling via the Space Shuttle. She has also been involved with the NASA NEEMO team, NEEMO 9 mission, to live and work underwater, and she is the founder of the Space for Art Foundation. Nicole, thank you for joining us.
Hi, it's my pleasure to be here. I, like the others, I think, so happy to be part of this celebration, Sarah Jane, today, and thankful really for this legacy, and I think the continuing inspiration and possibilities that are opening up because of that historic, Tektite 2 Mission 6. And I was so happy to see my dear friend Bill Todd this morning, who, I credit with making it possible for people like me to experience the ocean, to experience the undersea in a way that I would not have had otherwise.
Yes.
I'm gonna try to bring up my slides while I continue to talk here, but so I'm gonna share screen, and then I'm gonna go full screen, right? Yeah, let's see if that works. Do it. There we go. Is that good?
Joe, oh, you need to pick an application.
Okay, sorry about that.
That's all right.
I knew there'd be something. There we go. Share. That's better. Look at that. Look at that.
That's it. And then, yes.
Excellent.
Perfect.
Okay. All right. Well, as I share these slides quickly today, I'm not going to concentrate on the science or technology that went into either, I think, my space or undersea mission, but more really reflect on the relationships and perspective of them, and continue, I think, nicely, hopefully, with what Pascale was saying through this perspective of our planet. I have found that our space and our sea perspectives provide us with this equally compelling understanding of our planet as our life support system. And they present to us the challenge really to be crew members and not passengers here on Spaceship Earth. This first slide I share because I get asked a lot what it was like to be in space. And this one picture kind of captures it all in one picture for me. It's really beautiful. As you can imagine, it's beautiful in space to be looking out the window of your spaceship. But I look at this and I see this silhouette of what looks like a very still space shuttle in space. And yet I know that we were traveling at 17,500 miles an hour, or about 5 mileseconds around the planet, which means every 90 minutes we would orbit the Earth and get one of these really stunning sunrises or sunsets out the window. I also know that I'm inside of that silhouette with my crew after 3 months in space and returning home to my family. And I know that my friend Jeff Williams was still on the space station, and he took this, really beautiful memory for us, out the window of the space station. I had the opportunity, as was mentioned, to spend time in both living and working in inner space, to prepare and live and work in outer space. And we kind of joke about that as astronauts, you go live in inner space to live and work in outer space. And as Bill described this morning, this is absolutely, bar none, the best analog to living and working in space, to go live undersea on the Aquarius habitat. Not only an analog, but what I think is important is that these are real missions themselves, and they are real missions in a real extreme environment. And like the Aquarius habitat, which is a life support system that we've built undersea, the ISS is a life support system built in space. In both of these places, we've done the best we can to mimic what Earth does for us naturally. And the space station, I think, is absolutely the best example of living off the grid. I think it's a masterpiece in space. This, I think, as we mentioned before, is the 20th year of continuous human presence in space on the ISS, where we've been living and working peacefully and successfully in partnership with 15 other countries, with all of that work ultimately about improving life here on Earth. And I believe the ISS really and truly is the best example of how we should be living and working as crew here on Spaceship Earth. When I think about this, I think it speaks directly, to the idea of what was mentioned in the, in the opening panel session about being citizens of the reef. It's the same thing. Crew members on Spaceship Earth are citizens of the reef if we behave properly. We build these life support systems, in space and sea, so we can live there and work there. These pics are not meant to be, unprofessional in any way. I'll just share you that. These are both pictures that NASA originally didn't want shared. But I share them because I think it brings out our personalities, our humanity that we bring with us to these places. And we also know, I know by looking at the faces of these people in these pictures, that that we bring with us the ability, the professional side that we know we'll have each other's back when things don't go as planned in these extreme environments. We explore these places, both sea and space, because they give us the opportunity to look at things differently. They give us the opportunity to separate, I think, from what we think we know and make a better connection to who and where we are together in space. I am thankful, I can tell you, very thankful for the personal connection that I've been able to make with the planet through the sea that surrounded me and through the opportunity I had to surround it from space. There are no two better windows on or off the planet than these two. I am thankful for the opportunity that I had to feel my own idea of home quickly shift from being this particular place like Florida on the planet as my home to Earth, as a planet as my home. I am thankful for the surprises that these vantage points of sea and space provide that honestly make me believe that God must have a wonderful sense of humor. And this is why, our human nature of like curiosity and discovery and exploration is so important. I think we're meant to find and see and explore these beautiful places that are naturally there for us, like these two pictures show. I am also thankful for the awe and wonder that I saw through my spaceship window that helped me realize, this connection between all that I was seeing. And these two pictures in the top left, this is a picture of a tiny little chain of island on the northern coast of Venezuela called Las Rocas that I didn't know anything about before, but came soon to realize that the one place that I go diving most of the time, Bonaire, which shows up kind of like the little Florida-shaped island in the bottom right picture, also taken from space, is 50 miles from this place called Las Rocas. This one picture became very much an inspiration for me. I know these experiences and connections will inspire, honestly, will inspire the rest of my life. They have done so already. I made a connection with Las Rocas and painted it in space. Those things have been brought together in my life, like on what I consider my next mission to be, which is using art and the ideas of space and sea exploration to inspire children around the world to to understand their place here on the planet and in space as these citizens of the reef, as crew members here on Spaceship Earth. And I will close. I tried to move quickly. I'm going to close, I think, with what I believe is this all-important connection between sea and space. Sylvia and the others say it the best, but I honestly believe it's what keeps us alive, this connection. It's what defines our interconnectivity to everything and everyone that we share this place in space with. And in all of the complexity of what goes into space and sea exploration, I think what we come back to Earth with is very simple. And I summarize it in, these 3 lines, and it's really that, we live on a planet, we are all Earthlings, and the only border that matters is that thin blue line of atmosphere that blankets and protects us all. And in closing, I'll just say, I think it's really important for all of us to appreciate this simple, yet I would say profound perspective from whatever vantage points we are afforded, and that we accept our responsibility as crewmates here on Spaceship Earth. Thank you. All right, stop sharing.
No, please continue to share. That was so beautiful, and you remind us collectively that we need that mission mindset, and we need to embark on an appreciation for all kinds of perspectives that enable us to sincerely feel a part of planet Earth and it as our home. I have a question for you before we continue, and that is, because of your unique perspective and experience, you've identified that there is that fragile thin blue line, but in truth, is there a difference between sea and space?
That's a really great question, because I think, when I was on the Aquarius mission, and when I dive anytime now, when you're surrounded, I really feel like, wow, you're surrounded by the planet when you do that, right?
Yes.
And you get this almost, it seems like kind of a micro perspective, and yet there's this, awesome ginormousness that's surrounds you that you can't even begin to really comprehend. But I find, I don't know if you do this, but I find underwater, there's always a point in the dive where I just kind of lay back and look up, and there is no real distinguisher, right? You can see the surface, but it doesn't really, there's not an end to it, seems. It seems like it just continues right on into the sky. And the same thing is true when you look, you're immersed in this, you're looking out the window from space at this gorgeous blue line, and you see, and even in this picture, you see it just kind of, there's this fading, this blending that just kind of naturally happens. And you realize, I think that's part of that interconnectivity. It's all part of each other. Yes. And I don't know, I stand on the planet. I try to go out every now and then and just put my feet barefoot in the grass and feel this connection, the bottom of your feet, where you almost don't notice the difference between it and the earth, and look up. And there's this kind of contradiction, I think, that we look up, at least I find myself looking up and still feeling like, oh, that blue goes on forever. It just goes on forever. And yet, the bulk of it is I can drive, to Disney World from here, and I'm out of the atmosphere if I did that same driving straight up. And that's mind-boggling to me, how perfectly placed we are, distance from the sun, the way, and it drives a respect. It really drives a respect for how wonderful this planet is for taking care of us, and we owe it the same.
That's so true. That's so true. Well, thank you so much. Please stick around. We'd love to chat further with you. It's my pleasure to introduce another speaker, Dr. Darlene Lim, and she is also a NASA scientist. She's a research scientist who works in other space analog environments, but predominantly here on Earth. She has worked from the Mojave Desert to the Mars Horton Research Project in the Arctic. She has worked also on the NEEMO NASA Extreme Environment missions underwater. and she's been working at Pavilion Lakes and developing systems in a project that we're very interested in called Subsea, among many others. It is my pleasure to welcome Dr. Lim to join me here. Hello.
Thank you. Hi, thanks so much. I can only see my shared screen at this point. I apologize, I don't have another one. So I'm just gonna smile and assume you're still there. But yes. I just wanna say thank you so much to you, to Joe, and to your entire team for inviting me to be here today. It really is such an honor to be a part of these Tektite 2 celebrations, and really to be celebrating the last 50 years of collective advancement and knowledge gain in the field of sea and space. So thank you so much. I really look forward to viewing the entire program at its conclusion. But let me jump in because we have, I think, only 15 minutes. And so I was brought in by Sarah to talk about analog work that we've been doing. And I say we because I'm the lucky talking head that gets to be here today. But really, this talk is on behalf of hundreds, literally hundreds of amazing people that I've worked with over the last couple of decades, whether on the shorelines of various lakes, or underwater, or in the deep sea, or in the flanks of volcanoes. So all over the place, as Sarah mentioned. And so there really is an amazing arc of people and of experience that I'm going to be sharing today. But I'm going to focus on.
Excuse me, Darlene.
Yeah.
Just 1 minute. Sorry to interrupt because I know you can't see. We'll need to make sure the screen share is active again. So when you go to that screen share option, it will have three tabs at the top. You need to select the application window that can take you to the slides.
Copy. It said I was sharing. It said stop sharing. It actually says StreamYard is sharing a window.
Okay. So now we have it, I think, coming up. Now we have it. That's correct.
Perfect. Okay, good. Yeah, I think there's probably just a bit of a lag. All right. Terrific. Can you see the front screen now?
We are still we can see your layout pages. And if you click on that as full screen.
Does it come up now?
There is a bit of a lag, you're right.
Mm-hmm. You know what I'm going to do is stand by. I'm just going to make one minor adjustment to the way that I'm communicating into.
A little message from Joe, if you can hear us, Darlene, is that the bottom right-hand corner will work as well to go to full screen. But we understand this is no different to any type of mission out in the field where communications are always, and compatibility between systems and particularly network systems across jurisdictions, countries, hardware, software, etc., is always a bit of an issue. So we apologize for the delay, but Darlene is well and truly versed with way more complexity than this, and she will sort it out. Another thing that we can do, Joe, if you'd like, we could go with a message in a bottle, if there is. Oh, we have Darlene said, I am back. Brilliant. Well, I don't know about you, but I will say that this is Tektite 2020, Women of Sea and Space, and we are streaming live. So we're working with a system called StreamYard that can stream live to both the Facebook channel and the YouTube channel. So we ask you to join us on either Facebook or YouTube. The live comments are coming through to us, and we can ask the speakers your question. Darlene, great to have you back. Let's try this again.
One more time. Let me try this out.
Super.
How about now? Can you see it?
We can see it's trying. So slight delay. Yes, we have the option of all of the screens, and we have the slide sorter.
Okay, stand by.
It's just disappeared again.
I think we have a massive implosion of technology right now. Stand by. I'm sorry to be your problem child for the day. It seems like everybody worked perfectly except for me, which is the worst from your standpoint. So give me 1 second. I'm going to do it one more time, nice and slow, and we'll get back on track very quickly. Stand by.
We have some support from the other speakers saying it wasn't just you. We had some other challenges as well with some other speakers. No need to feel bad about that.
Oh, I have guilt. I'll always have guilt. I'm a mother, so. Okay, can you see my screen? I am not going to touch anything until I think it is sharing, and I'm in full screen as per.
It is sharing, and we're seeing the slide sorter view. We're not.
Okay,
yet.
let's give it 30 seconds.
Okay.
And you know, I'll tell you a funny story while we're waiting.
Please.
Is that I actually gave a tech talk at Google, and they had a massive implosion of their distributed AV system the day that I went in. So I couldn't even bring up my slides in the room that I was supposed to talk in, which is hilarious. So I just ended up giving the talk without slides. So we can do it that way too, you know, or I'll just pantomime or something. so there are ways around this.
I must admit, the first time you work at NASA Ames campus, the first time I was at NASA Ames, I was there for a 3-month kind of session of study. And we had no Wi-Fi on campus after hours. And I say, we're at NASA Ames, and we can't get a Wi-Fi signal. This is crazy.
It's always like that. Yeah, exactly. So you let me know, just like break in and tell me when you start to see my slides. From my perspective, I'm actually showing you a slide. And I'm not sure why it's,
okay.
I'm actually in full screen
now.
Yeah.
There's an option on the right. Joe is just
but what I'll do is I can just talk to you.
Darlene,
can you still hear me?
When you can see all the slides, there's a slide sorter option in the bottom left, and the middle one is clicked. I'm wondering if you click the one on the right, if that'll bring it full screen for us.
I did, yes. I have been doing that, and it's not working. So let me try. I'll click this. Yeah, we'll just do it this way. Let me see if that one works. The different buttons. But like I said, you know, you will if you're just seeing the full array of slides, that's a bummer. And I have clicked. It apparently is in presentation mode. It should be showing hopefully soon. The alternative is I'll just start talking. And
I wonder, I do have one other suggestion. Perhaps you are sharing screen, but not sharing it through the application. So if you go back to the share screen button, don't touch your presentation, but the share screen button at the bottom of StreamYard. And when you click share screen, it will come up with share your entire screen or window application in the middle. Click window application.
It is.
And one of those should be PowerPoint specific.
Correct. Yes, that is exactly what I've walked through. Yeah, so we're having some hiccups. I'm not really sure what that is. But can you actually, so it still says that I'm sharing just this application. Can you see the array of slides right now?
Yes.
Okay.
Let's just go with it.
How about this? Can you see this?
That's better. Yes.
Okay. And then I'm just going to do it one more time, just in case, because I think the issue is when I go full screen, there's a hiccup. Can you see this? This is like going to the eye doctor. How about that? No? It's not full screen for you?
No transition for us, but
okay, that's all right. Well, let's work this way. I think this will work out. And we'll just jump into it then. So I think, you know, if we go to some of the questions you've been asking people, what have we learned? Over the last 50 years, I think it's what you just saw today, is that you don't know what you don't know. And so everything was working great until right about now. But as I mentioned, I'm going to be talking about aquatic analog research programs. I will touch a bit on some of the Earth-based activities that we've been doing over the past decade or so. But I do want to focus on the research that has really arced in the aquatic environments through time and is really all joined in the realm of trying to explore this planet as a means to understand other planetary exploration. So one of the focuses of our teams has actually been on EVAs on the Moon and Mars. So EVAs are extravehicular activities. They are exploration activities that one would do on the surface of another planet, or our Moon and so forth. And so we're looking at the fact that along with robotic exploration, EVAs will become a primary means of planetary scientific exploration as we move on, back to the Moon and onwards to Mars. Now, the thing that we have the advantage of when we're working here on Earth with other scientists, as an example, is that we get to go typically to the environment that we're working on, that we're interrogating, that we're curious about, and we work as a team. And so we're able to have conversations with our peers right there in the moment, make decisions about which sample we want to collect, if some piece of equipment isn't working, if the computer goes down or the network goes down, or perhaps your spectrometer is having some hiccups that day. There are always people around who are resourceful, who can sort of work through those issues so that we can get to the science objectives at hand. Now, what's going to happen in the future is that as we move humanity and humans and robots in tandem further and further out into space, is that there will be an increasing communication latency between the Earth and, let's say, we go all the way to Mars. And what that means is that, for example, right now I'm talking with you all, and as I was having a conversation with Joe and with Sarah, there was no time lag. We were just having basically a conversation, a phone call, as we're all used to here on Earth, where everything is optimized for speed. But as we get into a realm of, say, having a human operate at the south pole of the Moon and having a group of scientists reside on Earth here, or even a robotic asset on the Moon and having a group of scientists on the Earth who want to sort of communicate with this asset or with these humans as quickly as possible to make these sorts of scientific adjustments and changes and decide which sample to pick up, then we're going to be contending with, in the case of the Moon, about a 1.3 second one-way delay, so greater than a 2-second round-trip delay. And as we get out to Mars, this increases to about 3 to 22 minutes one way, or greater than 40 minutes at its worst case. So how do you enable these conversations that are so important here on Earth to propagate when we're in these more difficult operating environments? So that's one of the main focuses of our group, and we've been exploring this in a variety of different settings and specifically different analogs. And so just to define analog for the audience, we sort of broadly characterize an analog as a place on Earth that allows us to approximate operational or physical conditions on other planetary bodies within deep space, and lower the risk environment within which to learn, to make mistakes, to refine our knowledge, technology, and processes before we embark on our spacefaring missions. And throughout these science-driven analog missions, we get to learn about the geology, about the biology, the chemistry, and physical complexities of our very own planet Earth. So one of the analogs that I've had the joy of working in, as a team on, is the Pavilion Lake Research Project. And Pavilion Lake is a lake that's about 6 kilometers long and 2 kilometers wide in the interior of British Columbia, Canada. And with, this is the surface of the lake here. It's beautiful. And then if you dive down beneath its surface, you'll find that there are very large structures called microbialites. And these microbialites are rocks, they're carbonate rocks that have been built over time by microbial interaction with their environment. And we can see down at a very small layer that there's been incredible amount of buildup over tens of thousands of years. And so we use this lake initially as a scientific portal into understanding systems and life systems that may have been around in early Earth, during the early Earth's history, but then also as a portal to consider, as Pascale brought up, other aquatic environments in our solar system. But what we also found is that the work that we were doing, the science that we were doing underwater, had a lot of operational elements, as have been brought up through the variety of other talks today, that were wonderful analogs to operating in space. And so as time went on, we actually brought in a multitude of different assets to explore this lake for the purpose of science, but also for the process of learning about operating in these extreme environments. And during the period that this project was underway, we were moving through the prospect of going back to the Moon, as well as exploring asteroids. And so we brought in, for the initially for the purpose of science, these single-person deep worker submersibles into Pavilion Lake. We also continued to have a diving program, as well as we had ROVs and AUVs, autonomous underwater vehicles, working to do things, if I back up for a moment, such as create these incredible bathymetric maps of Pavilion Lake. And so this particular bathymetric map, I'll actually come back to it, and not so much the map itself, but the person who did it and his team, Art Trembanis, who's at the University of Delaware. So we work together here at Pavilion Lake, and he comes back into the picture as we move on to NEEMO. But what we did out at Pavilion Lake is we actually connected the assets that were working underwater, the humans, the submersibles, and everybody working in tandem through a communication network that enabled us to connect humans that were sitting on land into the adventure and the process of scientific discovery. And to really make this similar to operating in space, what we did is we put in a one-way light time delay of about 50 seconds, which at that point in time was akin to the time lag between the Earth and some of the asteroids that were prospectively going to be explored. And so this experiment here involved the astronaut Mike Gernhardt, and through his leadership, we actually then evolved the work that we were doing and integrated it into NEEMO 15 and 16. And so you see a group picture up here with a variety of different scientists, engineers, and operations researchers, and we managed to work with the Liberty Star and actually deploy the deep worker submersibles from the Liberty Star in the first year, and separately on a different vessel the second year. But in this circumstance as well, we were working to connect a group of scientists on land with those that were operating at NEEMO underwater and try to understand, again, how to enable science and exploration under these very difficult working conditions. And so this is an image here that was constructed by Art Trembanis, and it shows there are so many different sort of complex moving parts that had to be coordinated, and we had software systems that we brought into play, something called the Exploration Ground Data System, which synthesized all of the moving parts, the data, the information, in a way that was readily consumable by scientists under the constraints of the time communications that we experimented with, as well as the simple fact that operating underwater and then trying to communicate with those that are not underwater can have its own hiccups inherent to it unto itself. So this, again, I was saying that art has been, through the arc of all of these different aquatic projects, and so these bathymetric maps that I think many might still be using of Conch Reef here were actually produced again by him and his team. So you see that there's this amazing progression. These one-off analogs can get connected to the next, to the next, to the next, and each of them may have a subsequent build in terms of the objective, and they may be somewhat disparate, but in terms of the personnel and the knowledge that we build up, there's this wonderful, wonderful heritage that continues to propagate through the system. Now, most recently, we've been working in the deep sea on a different project that I've had the joy of being a part of called SUBSEA. SUBSEA stands for the Systematic Underwater Biogeochemical Science and Exploration Analog. And this is funded by primarily by the NASA P-STAR program, but also with a substantial amount of in-kind support from NOAA and the Office of Exploration Research, as well as the Ocean Exploration Trust. So again, a wonderful partnership, and this theme, I think, seems to be showing up again and again throughout all the different talks. So subsea research informs both strategies for conducting science via teleoperations at deep space destinations, and also to expand our understanding of a wider range of deep sea analogs for ocean worlds environments. And it included 2 different cruises, one to the Loihi Seamount, just off the coast of the Big Island of Hawaii, as well as to Gorda Ridge, which is just off the coast of the California-Oregon border. And we had 3 objectives that we've been working towards, one in the natural sciences, again, very much focused on understanding these unique hydrothermal systems that we were exploring as an analog to these ocean world systems. They had very specific ranges of temperatures and pHs that we were examining. And then there was a social sciences research component, which equally was of value to this program as the natural sciences and technology. And the social sciences aspect was looking at the domain of exploring at sea with through telepresence with a group of individuals, of scientists sitting on land, and again, trying to communicate through experimental as well as through kind of business as usual conditions. And so the social scientists were really trying to understand these operational processes as they might pertain to how we will conduct ourselves on the moon and then further on into deep space and then onwards to Mars. Again, with technology development, we were looking at the synthesis of data very rapidly and being able to share that out with a variety of scientists so they could decision and action on what they were seeing, you know, hundreds of kilometers away. This project, as I mentioned, involved the, you know, very tight collaboration with NOAA, and we operated on the ship Nautilus, and of course had these amazing ROVs as the workhorses of our program, Hercules and Argus. And then important for me to mention is that, again, there was a group of scientists who could not get on the ship, but who were co-located at the Inner Space Center at the University of Rhode Island, who were connected via an incredibly robust communications network into our mission every step of the way. And operationally, we were using this subsea experiment and the work that we were doing, again, that's driven by science, to examine the question of, you know, this telepresence model as being of use in the future when we perhaps have astronauts orbiting around around Mars, pardon me, while we have surface assets operating. So again, that would create a very low latency operational environment, but you know, you would want to transmit that information back to Earth, which is a high latency condition. So lots of very fascinating experiments that went on, you know, within this one project alone. But again, a lot of the people that have been involved over the years and the knowledge that's been gained, not only from the analogs that I've brought up, but so many others were certainly tapped into as we move through the development of subsea. I also just want to mention, of course, like I said early on, we work on land. So there's another project called Basalt that has examined EVA and scientific EVA conditions as it pertains to exploring on Mars and these communication latencies. And so we delved into so many different aspects of you know, work domains, if you will, and you can access a subset of the grander base of papers from this project through astrobiology. It came out last year in March of 2019, and there's a URL listed on the front there. The last slide I wanted to show, sorry, go ahead.
That's okay. No, thank you. Continue.
Okay. The last slide I wanted to show is that, you know, continuing on this theme of an arc, the way that we've been learning about how to communicate during EVAs, despite these communication delays, is now actually coming to bear on robotic missions that are headed back to the moon, such as the Viper mission. So the scientific operations related to this lunar rover mission are really interesting because we will be able to decision at a pretty fast clip, at a cadence, which is we don't really have an analog for in the robotic community. So in fact, if we look at the Apollo missions, that's probably a better analog, or some of these analogs that we've been doing is a better analog in terms of the speed with which the scientists will have to make decisions.
Fantastic.
So I'll stop there because we had a little loss of time at the beginning, so we can talk about some questions. And sorry that I became the problem AV person here.
No, that's all right. That's all right. And you work on complex communication issues across greater scale, so there is some irony there, but we understand that. I want to thank you, and also to bring all of the panelists back in. Peter has had to leave already. He is working in a different time zone, and it's a business day for him. But I have a question for all of you that I think relates to the diversity of your perspectives and topics. And that is, if we are to take some of the challenges that we face and to look at the true synergy between sea and space operations, when do you think we're going to see an international undersea habitable station operating just like we do at the International Space Station? When do we see those partnerships occurring within what has traditionally been a maritime industries where the demarcation and divides are pretty clear? Pascale, let's go with you.
Well, I'm actually the space expert, yeah. So
exactly.
I think I leave the time scale, you know, to the experts of the deep sea. But I think what is really necessary is to have more interaction and a dialogue between space and the maritime stakeholders.
Yes.
To share experiences and also solutions, and to co-develop, you know, necessary innovations. So I think you know, the dialogue has to be increased, and I think the oceans can, being not a perfect expert on the deep sea, can really learn, you know, from what we are doing, because despite the ocean floor is very close to us, yeah, and compared to the International Space Station. But we have mapped, you know, really a lot of our neighbor planets, of the surface of Mars, and we have mapped, you know, the surface of Moon to a very large percent. And I think we have only mapped, I don't know, I think I've heard that 19-20% of the ocean floor. So this is something, so we have actually least explored regions, like for instance, also for extreme life, we know actually very little about, even on our own planet. And I think that's why the synergy is really important. So for the time scale of a real, how do you say, international space station, station in the deep sea, I would refer to experts. Yeah.
Darlene, Nicole, you're on mute. If you'll need to unmute if you.
Yeah, I think I'm on. Can you hear me okay?
Yes, perfect.
Okay, fantastic. Yeah, I echo what Pascale said. I think there are so many, you know, there are so many opportunities at hand right now
Yes.
for partnerships. As I mentioned, you know, some of the funding that we've received recently has been in partnership between NASA and NOAA. And that's even complicated unto itself to do these sort of one-off, you know, 3-4 year endeavors under those partnership conditions. But I think, you know, as we get more familiar with this type of opportunity, then ideas like you just presented will become easier to digest and to discuss. But one thing I think that is easy in some ways to partner on is technology development, simply because there are lots of you know, synergies between, for example, the need to support a bevy of scientists and their ability to understand what's going on in these remote environments, whether, you know, on the surface of land, on the surface of oceans, underneath, or in space. These are kind of common themes, and we're finding this these common themes to be more and more, I guess, you know, exciting to talk about, because people are really trying to be resourceful at this point in time and find funding as a team versus as kind of disparate stovepipe environments.
Yes. So Nicole, if we just follow on with that, how do we tackle enormous, complex challenges like climate change if we can't cooperate singularly together on an integrated global mission in this area? Or is it a case of regional development?
Well, I mean, I think we have cooperated, and I think we have demonstrated that we can do these kinds of things, that we can find solutions to very complex problems. And, you know, from everybody at this, you know, at this panel today, we heard about the international aspect of that too, yes. How it's really not one little corner of the world that's doing this anymore. We understand we have to work together to do that. And I would, you know, I mean, there's so much going on in terms of celebration at this time, you know, 51 years of Apollo 11, where even those guys were like, hey, this is not just about the two of us walking on this body. This is about humanity, right? 45th anniversary of Apollo Soyuz. I mean, you know, talk about, you know, that handshake that was this real driver for, you know, pulling us more out of race and competition into cooperation. And that we see, I think, so beautifully from a space standpoint on the International Space Station now. But I know, you know, it was happening, you know, under the surface of that ocean as well. And I don't know, I have this little guy here that I always share, this, like, you know, the motto from my friend and mentor Jay Honeycutt, which is here's how we can, not why we can't. And what I've seen from everybody that's participated so far today is that's whether they're using those words exactly or not, that's an approach that's going on. It's like, okay, we've got a problem. We are going to find the solution. We're going to figure out how we do it, not, bicker blah, blah, about why we can't. I don't, I live in a place right now. We're in St. Petersburg, Florida. We're right down the road from the pier that just got renovated where SeaQuest was filmed, right? It's like flying cars. I expected that whole SeaQuest reality to be here by now. Sadly, we all have to kind of be patient, I guess. But I don't know. I think it's see it, be it. I watched the work that the three of you women are doing and that Peter shared with us, and we're moving towards it, right? And there is so much we don't know, right? We think we know so much we don't know. Pascale, I think you just mentioned something about, kind of the otherworldliness of the planet itself, not even just the ocean, but the planet itself. And I don't know, we're meant to discover it. We're going to do it. I cannot give you any sense of time when that will be. But my hope is that from both the sea and space standpoint, we'll be pulling together to make both of these frontiers explored to a greater extent. And I can tell you there is not a single NASA astronaut, ESA astronaut, Canadian astronaut. I'm not, European, I'm not sure if we've had Russian astronauts on Aquarius yet that have gone there and don't want to see the ocean explored to a greater extent, in parallel with what we're doing in space. I think you have some of your greatest proponents, from that community. And if we can figure out how to use us in a better way, I think we'd all support as well. So.
Brilliant. Ladies, I'd just like to conclude. This has been an amazing session, and you're doing incredibly important work and inspiring work, and we've had different perspectives from mission architecture to system-wide governance to technical realization right through. But what is, from each of these perspectives, what is your call to action? What is your call to action for the next 50 years? You've all hinted at it. Is there something that we could positively say and communicate right here and set our intentions towards? Because we are looking back, we're inspired by 50 years of incredible work. We see the opportunities, we recognize the challenges, we know implicitly and intuitively that there is a long road ahead, that this is a slow build, it is a cyclic build sometimes. But what is it that we can do from this vantage now today to I guess look forward or move forward, dive forward, splash up?
So I have a thought that was inspired by a conversation with my 10-year-old daughter last night, and I think we can celebrate, but we should also be reflecting during this period of time. And she was telling me about one of her soccer favorites, Abby Wambach, and how Abby Wambach wrote a book where she examines the old rules and the new rules that she wants to abide by, and she would like to really put in place around leadership. And I think as a sea and space community, we can do that as well. We should be able to reflect. We should be able to question some of the, whether it's cultural structures or philosophies or historical narratives at this point in time, because we are living in very interesting times, and I think we should be able to do our part to be as as thoughtful and as deeply, considerate of what's happened in the past, and try and rework and relook things that I think we've taken as a given. So that to me is my hope, anyways, for future generations.
Brilliant.
I have a little thought that when you look at climate conferences, all over the world, space applications, Earth observation technologies are not the main point, in those discussions. And we really have to bring it, on the table. We have in these really large scale meetings where we are looking at the planet globally, and at many different, issues, I think we have really to show, that for the future protection and for the sustainable development, of ocean resources, and space really can contribute a lot. And we can protect, marine ecosystems, and we can monitor the climate changes, pollution, so many things. And I think this is not so visible, and it is not so well known. And we have to really to establish this dialogue that in the climate change and environmental committees and large meetings, space plays a more dominant role. Space technologies.
Yes, brilliant.
Of course, I also want to investigate all the moons and all the planets in the sky, but that's another thing.
That's in parallel.
Yeah. Thankfully, all that stuff brings good stuff back to Earth too,
Yes.
I agree with everything that was just said. And I look at this connection between sea and space as our way to understand that what we all are sharing in common between that is this planet, this life support system, right? And that should drive a call to action for all of us in one way or another. You don't have to go to space to appreciate that. Honestly, I don't think you have to go dive in the ocean to appreciate it. There are vantage points that surround us always that can allow us to take that in. And it's finding common ground, I think, figuring out how to find that and take action on it, to be the crewmates of Spaceship Earth, to, sometimes it's not, there's this phrase, the Navy SEAL phrase, like the pleasure is the pain. Sometimes we will have to get uncomfortable to create the change we need here. And I think that, what you guys are doing too, whether it's the monitoring from space, whether it's looking at the world from under the ocean, that is the data that we need to help make these decisions. And how we present it is important. I think, Pascale, you're right. We should be throwing the benefits coming back from space into every, conference where there's a challenge that needs to be dealt with, and presenting it in a way that, encourages people to take action, that makes some connection to them that we kind of struggle sometimes, in our science communities with doing. And I don't know what that answer is, but I feel like it's getting better and better all the time, honestly. And
I think you were hinting at the answer is culture and the arts.
Well, that could be that.
Did I hear that?
Yeah, you can take that. I mean, you, Sarah Jane, you and I know for sure that there are very creative ways to make connections with people, and I think what we're going to see over these 2 days is going to be, part of that solution for expressing it that way.
Yes. Well, thank you all of you for your extraordinary work and perspectives, and the work that you continue to do. Please let us know how we can support you in this bigger, broader global mission, and we look forward to all of the work that you're doing. I'm going to close out here, and thank you all. And we're going to go to a short little video to our next session. And thank you. You can be in touch with all of these speakers via Facebook and the YouTube live session. We also have a Slido session where you can ask questions that will be answered over the course of the few days. We are going to what is called a message in a bottle. This is from both two Aquanauts, Dennis and Claudia Chamberlain, who themselves have had a long association with the sea and space synergy.
Hello, I'm Claudia Chamberlain.
And I'm Dennis Chamberlain. We're lifetime explorers and Aquanauts. We spent over 30 days on more than a dozen Aquanaut missions, including the planting and harvesting of the first agricultural crop grown in a habitat on the seafloor.
Dennis designed the Scott Carpenter Space Analog Station for NASA, named after the first astronaut Aquanaut, and we used it for 2 Space Shuttle flight concurrent missions, Atlantis' 11-day STS-86 and Discovery's 10-day STS-95 John Glenn flight. To us, exploration of the unknown worlds below our ocean and beyond our home planet is all about establishing colonies. We founded the League of the New Worlds to enhance research, technology, innovation, and exploration to establish sea and space colonies like the Atlantica Expedition's first permanent undersea colony. May the next 50 years find families happily living and working beyond terra firma.
Well, that was brilliant. We had a question, so thank you, Dennis and Claudia Chamberlain. We had a question and a comment from them, really enjoying the conference as it proceeds today and wishing their best for the original Tektite crews and the early Aquanauts. Moving on, we're going to take this inspiration and move into what is more of an immersive space. Today marks the occasion of what it happens to be World Listening Day. And it is my great pleasure to introduce to you an Australian sonic artist called Dr. Leah Barclay. Leah has combined a practice working with research and sound engineering at the intersection of art, science and technology, and tapping into the deep bodies of water and ocean. Leah, welcome. Thank you for joining us live from the Great Barrier Reef at what is our local time of 2:46 a.m.
It is indeed. Yeah, thank you so much for having me. Yeah, it's an incredible program and it feels like a wonderful privilege to be part of it.
We're delighted you can join us, and we're looking forward to your immersive performance experience.
Excellent. So I can just very briefly introduce it. So the sounds that you're about to hear are hydrophone recordings, so underwater recordings from mostly the Great Barrier Reef, but the southeast coast of Australia. So these are recordings that have been captured over the last decade, and it's using quite experimental recording techniques. So rather than just a traditional hydrophone that might be focused on one particular species, it's much more about capturing the acoustic ecology of these marine ecosystems. So being able to hear from the perspective of different species as well. So this will be a live mix of different hydrophone recordings, and we're going to do it in a slightly experimental way. So I'm going to share my screen and swap systems, and in a few seconds you shall be hearing both live hydrophones and a mix of these recordings from the last decade. I'm just sharing my screen.
Are you able to go to full screen there, Leah? There. Oh, maybe not.
Is that a good enough view at the moment?
Perfect. We will go with that. Thank you.
Okay, excellent.
Leah, there is no audio. It should have sound. It should have sound. Joe, can you stop her, please, or let me speak? Leah, thank you for that. We're just not getting the audio signal there. We're not getting the audio.
Sorry,
There's no audio coming through to us, Leah. We'll need to.
Leah, when you shared your screen, did you choose the Chrome window option and tick the little box at the bottom to make sure the computer sound came through.
I did, yes. I'm getting it all loud and clear here. So you weren't getting that audio at all then?
No, not at all.
Sorry about that. It's coming through both systems here. No problem.
I think we made the test without your headphones. Was that correct?
Yeah, I'm just monitoring through the computer. So the stream is still coming through this system in the exact same way we tested it. Shall we try it one more time, or shall I talk about it?
It would be great to have live performance experience.
Let me just try one more thing. All the settings are exactly the same as our sound check.
Joe, you have the link also to the live page that Leah has. Are we able to run it through your system? Because I believe once she has her headset in, it changes things as well.
Leah, let's give the share screen one more try. And then if that doesn't work, send me the link and I'll try and play it on my end.
Leah, you are muted as well. And if you could just send that link on the private chat to the right.
Sure, yes. So shall I try it one more time from here, the screen?
Yes,
I've restarted.
And while we're waiting, Joe, I might go to another message in a bottle. I can run that here locally.
So can I just double check you're seeing the screen share and getting audio?
We are. So just talk us through it. This is the system that you've put up with Biosphere Soundscapes on a live website, Leah?
It is, yes. So we should be getting the live audio through now. I'll just run one more check through the system and it all appears to be running perfectly from this end.
We might provide the link so other people can look at that later. It's not coming through. Do you have a pre-recorded version we could play?
I do. Let me just push the audio through. Are you getting audio now?
No, we're not.
I'm really sorry about that. I'm not sure why it's not coming through because all of our settings are the same. Very sorry about that. Shall I talk you through the piece instead?
Yes, please. We've had some other comments. There's a problem with Joe's headphones being plugged in. Maybe, Joe, if you take out your headphones.
I'm not using headphones.
Oh, that was the comment. And below, one other last check, and then we can just go to chat, is that cam mic link at the bottom of your StreamYard settings. Just check those. Click the settings, go to audio, and just make sure that the input speaker is what you expect. Leah?
Yep. So all of my settings
they can change and change to defaults once you change one setting. So just double check that again.
Yep. All my settings are exactly the same. So.
All right. Well, let's have a talk about the process. Is there something else that you can play us that is offhand?
Well,
can we share the link? Because we have a live audience, and it would be great to hear something. And you can talk about live listening day for us.
Sure, I can definitely do that. I mean, if Joe wants to grab that link, I can still do the live mix from here and play it through that system. That, in theory, should work in the same way. Otherwise, I can share a pre-recorded link for the work. But
all right, Leah, we're waiting for that link on the private chat on the left of the screen, and we can get that started. And we've got 5 minutes left, so here we go. Great.
So you're pulling up that link right now?
I hope Joe is. He has access to that now.
Excellent. I mean, I'm happy to chat through
Please.
and the focus of this work while we're waiting. Okay, so we have the link running live. All right, so I'm going to set up the mix again. If that's running, it looks like it is.
So where are we listening from?
Currently, we're listening from the Great Barrier Reef, and also recordings being mixed in from Fraser Island, the tip of Fraser Island.
Oh, beautiful. Still no audio for us, Leah.
Coming through now?
Yes, a little, very faint.
Right. For the technical problems initially.
That's all right. No, it's so beautiful. It's so beautiful. You connect us very deeply, and it reminds me of what the Aquanauts are talking about: being in situ, being there, being in an immersive environment, and being able to have that proximity to the data that they're collecting. We have people who are working on these big, complex space Earth observation projects and really trying to understand the nuances of sensory technology in order to be able to detect and to sense life and dynamic systems at large. But tell us what it's like from an artist's perspective, to be able to have an instrument, a sensing instrument that enables you to have a tether into a body of water and to be a kind of a sensory, have a sensory portal into that world.
Yeah, look, it's a pretty incredible experience. I mean, quite different from diving as well, because I guess, when you're diving, you're always hearing yourself, and your sonic environment is very much kind of dictated by the sound of yourself breathing. So I think, being able to drop the hydrophones into the water and be immersed in this sonic environment that, truly is a sonic environment. I mean, the ocean is a world of sound where marine life are literally reliant on sound to communicate and survive. So it's, always quite unpredictable, but such a compelling place to listen, and, always my favorite place to be listening underwater. And I think, it's sort of fascinating now where we know we can learn so much from those soundscapes. The amount of data we can extract through particularly those long duration recordings is incredible. But obviously, from a creative perspective, the thing that I love most about it is, the soundscapes being able to give us that embodied connection with marine environments.
So talk us through some of these longer extended durational works that you have produced. You've worked with scientists, technologists, you've adapted technology specific for the task, and you've gone out into the environment. How do you orchestrate and how do you compose a new work from that? And does that experience, do you have multiple layers to the experience of engagement with the aquatic domain?
Absolutely. I mean, I guess for me, these interdisciplinary projects, it very much is about engaging with that environment in a very embodied way. And I mean, it's pretty rare that it would be one creative project that comes out of it. It's usually multiple presentations and performances and soundscapes. And I always sort of have quite a strong participatory focus to the work. So recording workshops and composition workshops with the local community as well. But yeah, in terms of the composition process itself, when I'm talking about working with 6 months of data or something like that, I mean, it's often, a very intuitive process in the studio where I'm processing sounds and layering sounds and listening, a whole lot of listening to, all the material that's being recorded. And I worked out, just a couple of months ago that I would not be able to listen to all the material that I've recorded in my lifetime because there's just terabytes and terabytes of data there now, which is both overwhelming and exciting.
Oh, very much, very much. And what can you tell us about, particularly with the long duration works, what can you tell us about the state and the health of the ocean? And is that something that you creatively manipulate later for another type of experience?
Yeah, I mean, so the kind of recording techniques I use are also capturing ultrasonic and infrasonic sounds, so sounds above and below a human hearing range, but quite a common range for different marine species. So I am manipulating the sounds for creative works in a way that we can perceive them as humans. So with the idea that many of the installations are about listening from different perspectives. So, being able to sort of trace those sonic migration patterns and be immersed in these environments, and, listening from the perspective of a snapping shrimp or a humpback whale. So I definitely am manipulating the sounds, but I would say not in an implausible way. And I think when we're talking about the sort of sonic health of marine environments, I mean, ocean noise pollution is just as much of a crisis as every other crisis we're facing at the moment. And, we're seeing an increase of things like seismic testing, which, is the equivalent to having a nail gun in your bedroom going off every 15 seconds. So the level of, trauma and impact that is causing for marine life is just completely detrimental. So I think, in terms of using sounds to both measure the health of marine environments, but also to bring attention and awareness to the impact, the detrimental impact of noise pollution, is,
Yes.
you know, a really important way to draw attention to that as well.
So talk us through, we've just listened to a piece taken from Fraser Island and the Great Barrier Reef. Talk us through that, and perhaps talk something of the power of art and music and I guess the human expression that comes with this environmental collaboration.
Sure, yeah. I mean, I think it's interesting, you know, when we talk about some of those recordings and, you know, the impact of noise, for example, when, you know, we speak about it or when we read about it, I guess it affects us in a certain kind of way. But when we're actually immersed in those environments and when we're listening to it from the perspective of what it actually feels like to have that sound rumble through your body, it connects you at that sensory level. And I guess, you know, with a lot of this work, yes, it is based on scientific data, but it is about, you know, I guess giving humans the experience of feeling what it's like to be immersed in the ocean. And I mean, you know, those beautiful comments that Sylvia was saying earlier around, you know, we've got to get kind of decision makers in the water. Children have to be in the water. You know, people have to have these immersive embodied experiences with the ocean to care enough to want to protect these environments. And so for me, these creative experiences, these immersive soundscapes are about providing that, you know, embodied sensory connection and allowing people to feel immersed in these environments in a creative way. And I guess, you know, I am manipulating the soundscapes from different times of day and times of the year as well. So you're getting that non-linear experience of a marine ecosystem as well.
Beautiful. So Leah, given all that we've learned over the last 50 years and with things that are changing rapidly, not only with our communications, but with our biopolitical interactions and our environment itself, what do you hold and what is your call to action? What is your vision for the next 50 years ahead? And how can sonic composition and hydroacoustic composition and artists in general be in symbiosis as in cooperation with ocean activists and communities all around the world?
Sure. I mean, for me, I'm really passionate about collaboration, and I feel like the potential of interdisciplinary research and interdisciplinary thinking in the context of communities is such a powerful way forward. So to be bringing, you know, community together with artists and scientists, and I've been really privileged to work with First Nation artists in different parts of the world, and I really feel passionate about you know, creating spaces in research projects where we can really prioritise First Nation knowledge and look at how we can combine these different knowledge systems, from that incredible knowledge of the environment to artistic, scientific, and having that research embedded in the community as well. So I guess for me, you know, that call to action is always about working directly with communities and prioritising interdisciplinary research.
Fantastic. And just to conclude, perhaps tell us about World Listening Day and what we can be doing to bring conscious awareness to our environment.
Absolutely. World Listening Day is a global event that's celebrated on July 18th, which is the birthday of Murray Schafer, who's the founder of the acoustic ecology movement. And it's a day that is really about celebrating listening to the environment. And so I guess I would particularly encourage anyone to seek out all the incredible recordings of marine environments that exist online. There's no shortage of those, and to listen to these ecosystems and how they're changing.
Great. And is there a tip? Is it? Can I get a cup and put it up next to the water and hear? Is there something that we can be doing at home to hack the system and do this ourselves somehow?
To hack the system, as in build your own hydrophones, or
yeah, come on.
Yeah, super easy to build now. There's plenty of ways that we can be building our own hydrophones, plugging them straight into your phone and dropping them in the ocean whenever you're near a marine environment. I mean, the beautiful thing about that kind of technology now is, it is so accessible and affordable and easy to use. Whereas even just a few years ago, we would have needed an entire rig and $40,000 to get a hydrophone into the ocean. But now it's all at our fingertips.
Brilliant. So, and now it's up to us to do something with it.
Absolutely.
To take it in. Thank you very much for your time, and we'll leave it there. And we look forward to listening with you more and taking the time. It was a really nice way to settle back in and to make that deep connection. So thank you, and good luck with the rest of the performance for the rest of the day. I believe we'll put up a link so people can continue to listen to the Great Barrier Reef and to all of the activities going on around the world today.
Excellent. Thank you so much for having me.
You're welcome. Thank you, Leah.